Algebra 2, Lesson 8.2. We're going to be evaluating exponential functions in word problems. So let's read example 1. The radioactive substance cesium-137 has a half-life of 30 years. What that means is you'd have this mass right here. 30 years later, it would be half as big. So if it started off with 10 grams, now it would be 5 grams. So that's what half-life really is all about. There's radioactive decay. Here is an equation that will represent the amount that we have. So it says find the initial amount. The initial amount is always going to occur where t is equal to 0. Please remember that. What you'll do is you will plug in t equals 0 into this formula right in here. Now, what you can do real fast is get your calculator out, and we can type in 621. We can say alpha y equals, and we'll get our 1/2. And we're going to raise that up to, now I'm going to do another alpha y equals. We can see that we'd be plugging in a 0 for our t. And when we hit enter, of course, we'd get 621. So we'd have 621 grams to start off with. That is going to be your initial amount. So you're now going to have to take one additional step. You're going to say in 50 years. In 50 years, we're going to let t equal 50. Go back to what you just typed in. We can even go second enter, back arrow, and type over 50 instead of 0. When we hit enter, we'll get 195.6, and they're not telling us, they're telling us to go to the nearest gram, actually. The nearest whole number would be 196. So we'd get 196 grams. As we continue on, you can see that sometimes you've got something not necessarily with half-life, but something in regard to temperature in this regard. A can of soda is placed in a cooler. T, the temperature, is given by this formula. X is the number of minutes. Again, they're going to say, what's your initial temperature? What we've got to understand is initial temperature. Initial always means let t equals 0, or let x equals 0 in this regard, because here instead of having our variable as a t, it's an x. So I'll get the calculator out. You can see we're using our calculator a lot today. Say -4 plus 24. Where's e? Well, it's right by the 4. Right next to it, you see this ln button, but right above it, we'll have e to a power. And we'll type in -0.04 times 0. And you can see we're going to wind up with 20. So that's going to be 20 degrees Celsius. By the way, we're going to go to the nearest degree. Then we want to know after 20 minutes. Find the initial temperature. After 20 minutes, we're going to let x equal 20. So get your calculator out yet again, and this time we'll hit second enter, and I'm going to come up here, and instead of having x equals 0, we'll just plug in a 20 right there. And what do we get? Well, 6.78 degrees Celsius, but rounding to the nearest whole number, 6.7 is going to round up to 7 degrees. Let's go to the back page. You're going to see that very frequently. What you'll see in real life situations is you'll have exponential growth or you'll have exponential decay. R is a decimal. What you're going to have to watch out for is often it is given as a percent, and you're going to have to actually fix that and change that into a decimal. We're going to divide by 100. A is the starting value. And you can see we've got this formula, y equals a, parentheses 1 plus r raised up to t. T, of course, is time. Now, the wonderful thing is, even when you have decay, you might see that something goes down in money, monetary value. Like you buy a car over time, unless it's a vintage car, a car will depreciate and go down and decay. The value drops. So we're going to have these two models. Let's read example 3a. It says an amount 1,800 is borrowed. So I'm going to say A, this is what we're going to start off with. We'll have 1,800. It's borrowed for 6 years. We'll have T is equal to 6. We'll have 6.75% interest. That's going to be your R. But this is where we've got to be very, very careful. Percent means divide by 100. So your R is 0.0675. Please remember to always do that. If kids get a problem wrong, 9 times out of 10, it's because of this. The loan is paid back in full. How much must be paid back? Well, you know that this amount of money grows. When you're accumulating interest, this is a growth model. So we're going to have y is equal to a, 1 plus r up to the t. So this is y equals 18,000, pardon me, 1 plus 0.0675. And we're raising that up to the 6th power. So we can very quickly get this typed in. We'll say 18,000. I'll say here's a 1 plus 0.0675. We're going to raise that up to the 6th power. And you can see if we're going to the nearest dollar, the 66 cents bumps this up to 7 at the single dollar unit. So it's 26,637. That's how much money is accumulated. This is how much someone would have to pay back on a loan. Way more than the 18,000. That's how a bank or a lending institution makes their money. All right, so a laptop is purchased for $1,650. So we'd have that for a start. The resale decreases by 25%. That's how much it's going to be going down. So if we were to take 25 and divide by 100, that's R, and R is going to be 0.25. What will the resale value be in 5 years? So T is going to be 5. This is a problem where we're in decay. So we'll have y equals a, 1 minus r to the t. So we'll have 1,650. Here's 1 minus 0.25, and we'll bump that up to the 5th power. So we can do this real fast. A lot of calculator work today. So say 1650. Here we'll go 1 minus 0.25. We're going to bump that up to the 5th power. And you can see this is going to be an amazing drop. This computer is now only worth $392. And that's very typical with technology. You can see the value of your technology drop considerably. It's a decay. All right, so let's just see as we look at this last one. The half-life of a radioactive isotope is the time it takes to be reduced to half its initial mass. Starting at 110, how much will be left after 3 half-lives? So here's what we're going to start with. We've got 110. We're going to divide that by 2. We're going to take half of that, right? We don't even have an equation that we're working with in this regard. We could just keep having. We could say here's 55 grams. So this is 1 half-life. Let's divide by 2 again. And if we took 55, just hit divide by 2, we're going to be at 27.5. This would be 2 half-lives. But we need to go one more. We're going to divide by 2 one last time because we want to see what happens in 3 half-lives. We're down to 13.75. Now they want us to answer to the nearest gram. 13.75 would round to 14 grams. And we're done.